So we can go to the next question. Actually, when you're going to the question, actually this question is based on our chapter solid state. And when we are going to the chapter, we are always studying the concept of edge length and how to find the radius and everything. An element has a body standard that is given, that is a question that is BCC structure with a cell edge of 288 picometer. The atomic radius that you have to find, and actually based on the concept of the edge length, we know that concept, that is edge length A. The edge length A is the concept. Edge length A is equal to 4r by root 3. This is the concept. Edge length A is equal to 4r by root 3. This is a method to find the edge length of a concept. This is a method to find the edge length. Edge length A is equal to 4r by root 3. Now you have to find the atomic radius. That atomic radius R you have to find. The atomic radius R is equal to, how can you find the R? R is equal to root 3 by 4. Root 3 by 4 A will be the answer. Root 3 by 4a, and here it is given in that question here that a, that is the cell edge, is equal to 288 picometer. So you can directly substitute that a here, so you will get the answer like this, that is root 3 by 4 multiplied by 288, and the same thing is given here, that is root 3 by 4 that is multiplied by 288. You will get the answer. So actually see here, there is the question is not given in a simple form. It is actually given the same form that we get in the with the equation. Okay, actually this is also the direct question.
That don't want to go for the simplification.
No need of going to the simplification. Actually, it's a direct question. You will get this same single step itself. So you will get the answer here. Here the answer of the question will be 1 will be the answer. So we can go to our next question.
We'll move on to the next
question.
So the rate constant for a first order reaction is 4.606 into 10 power minus 3 second inverse. So they're asking to calculate the time required to reduce 2 gram of the reactant to 0.2 gram. Okay. So it's definitely from chemical kinetics.
Chemical kinetics chapter, and you have
so it's a first order reaction also. Yeah. So they're asking to calculate the time to reduce 2 gram of the substance to 0.2. Yeah. So we have the direct equation. T is equal to 2.303 divided by K log initial concentration divided by concentration at time T.
Yeah.
So we can calculate, because K is already provided. K is equal to 4.606 into 10 to the power minus 3. And RC, the initial concentration is 2 gram and final concentration is 0.2. So we'll go like 2.303 divided by the value of K. It's 4.606. The exact the double of 2.303 into 10 power minus 3 into log like 2 divided by
0.2. Okay, fine.
So 2 by 0.2, that will be 10. And log 10, that's equal to 1. So this answer, this is 1. So this is your answer. 2.303 divided by 4.606 into 10 power minus 3. Now we'll take this 10 power minus 3 to numerator. So that will become 1000. 10 power 3. Okay, so that answer is equal to 10 power 3.
And this will be half.
This will be 2.303 divided by the exact the double of 2.303. So it will be 1 by 2. 1 by 2 into 1000. So the answer will be 500.
500.
Very
direct question. And actually this type of a question is always asking for your public exam level also.
Yeah, it's a +2 level question.
+2 level question. Okay, actually see here students, it is not much a great task to find these numericals also. Actually this is a question based on our physical chemistry. And this question is also based on the direct substitution of the reactions and everything. No need of further explanation and everything. That is, you know the equation. That is, the T is equal to 2.303 K log R0 by R at a time T. Then you have to just substitute the values and you will get the answer like this. Actually, there is a need of only 30 seconds to do.
Just 30. Because and also I think most of the students might have answered this question.
Yeah, the most of the students, even though it's a problematic question, they are always
it's a common equation like T.
So here we got the answer, that is equal to
500 seconds will be the answer.
So we can go through our next question.
So that question is something related to organic chemistry. So they are asking like the reaction between acetone and methyl magnesium chloride followed by hydrolysis will give.
Okay, actually it is a Grignard reagent. That is
that will be a Grignard reagent like methyl magnesium chloride. And this is from our chapter alcohol, phenols and carboxylic acid. Some of the methods used for the preparation of alcohols.
Okay, fine.
So we have different methods like we can use aldehyde or we can use ketone to get converted to alcohols. Okay. So they can react. So we have like we are getting either we'll get a primary alcohol or secondary alcohol, or we'll be getting a tertiary alcohol.
Mm-hmm.
So we like if we are taking like methanol, so methanol HCHO plus Grignard reagent RMGX, they'll be giving primary alcohol. It's I think it's directly given in the textbook.
NCERT.
Yeah, NCERT textbook. It's given like if we are taking methanol and Grignard reagent, they'll be getting primary alcohol and any other aldehydes. Apart from methanol, if you are taking any other aldehydes other than this methanol, so any other aldehydes plus Grignard reagent, they'll be giving secondary alcohol.
Okay, fine.
And if you go for ketone and Grignard reagent, that will be giving tertiary alcohol. So they are asking like reaction between acetone and methyl magnesium chloride. So acetone, it's a ketone.
Okay, fine.
So it's a ketone, and like with Grignard reagent, we'll be getting a tertiary alcohol. So it's a direct question. So we'll be getting tertiary butyl alcohol for this.
That is, here it is acetone. That is
acetone. That will be like CH3COCH3.
Yeah. React with the CH3MgCl.
That's it.
So it will become tertiary compound like it. That is tertiary butyl alcohol.
And followed by hydro. We'll go for the reaction. We'll go for the reaction.
Okay, fine.
So the reaction will be CH3COCH3. CH3 C double bond O CH3. So it is made to react with, sir, like they are taking
reacting with methyl magnesium
chloride. So
CH3 MgCl. Yeah, fine.
Okay. So double bond will be shifted to oxygen.
Okay.
And this carbon will achieve a positive charge and oxygen will achieve a negative charge. So the CH3 group will go to this carbon and MgCl will go to oxygen.
Okay, fine.
So they'll be getting like a compound like CH3.
A complex.
Yeah, a complex. Like it will be like unstable, something like CH3. Now this is the CH3 from our Grignard reagent
and OMGX.
And CH3 and OMGCl.
Okay.
OMGX, yeah. OMGCl.
Okay.
Now we'll go to hydrolysis, H2O. On reaction with water, this MgCl will become MgOHCl.
MgOHCl.
Yeah, that will be eliminated. And the remaining, the H2O, like the hydrogen atom will be placed instead of that MgCl.
Okay,
so the product will be, I can write like CH3, COH, CH3,
and bottom also CH3.
Yeah.
Okay, so it is a tertiary butyl. There is the 4 carbon here. So tertiary butyl, and this is alcohol. Yeah. So we can say here the answer, that is tertiary butyl alcohol.
Because they don't want to go for this reaction because it's a ketone and it's a Grignard reagent. So the reaction between a ketone and Grignard reagent that will yield a tertiary alcohol.
Okay, fine.
Okay.
So we can go to
we'll move on to the next
question. Okay, fine. Actually, the next question, when we are going to the question, which of the following set of molecule will have a zero dipole moment? Actually, this is a question that is based on our chapter, that is chemical bonding. The chemical bonding we are studying, that is dipole moment. Dipole moment, you are studying dipole moment, that is equal to charge into distance. That's the equation, Q into R. Dipole moment is expressed by the equation, that is mu is equal to charge into distance, and we know that it is expressed in debye. Debye is a unit. Okay, we can go to the concept. And which of the having a zero dipole moment is asking. You have to find the zero dipole moment. So in the case of ammonia, it's the first option, and beryllium fluoride, water does not having a zero dipole moment. You are studying the structure of water and everything in the dipole structure itself. It does not having a zero dipole moment. And the second option, this is boron trifluoride, hydrogen fluoride, HF. How this HF can be a zero dipole moment? There is H is here, there is fluorine is here. It will be like this. So it does not having
it carries a dipole moment.
It carries a dipole moment. It having a particular value. And the case of third one, nitrogen trifluoride, beryllium difluoride, water is also coming in the third option. So it does not having a zero dipole moment. The water here also does not having a zero dipole moment.
So they can neglect
this concept. So the one is wrong, second is wrong, third is also wrong. So we can go with the fourth one. You are given by the concept of boron trifluoride, beryllium difluoride, carbon dioxide. Carbon dioxide having a zero dipole moment. And also you are given by 1,4-dichlorobenzene. So this will be having a zero dipole moment.
So it will be better if we go for the structures like for boron trifluoride, etc. So if you go for boron trifluoride, the structure will be. So here, the dipole of any two dipoles, if you take the resultant of any two dipoles, that get cancelled by each other.
Yeah.
Okay. Then beryllium difluoride.
Actually, in this case, we can say here this resultant dipole will be like this, and here the dipole will be like this.
They will be in opposite
direction.
direction.
Dipole moment will be equal to here equal to zero. And the case of beryllium difluoride also, when we are going to beryllium difluoride, I am just taking we can say here I'm just taking a beryllium here, and the fluorine is coming here, and the second beryllium here.
It's a linear molecule.
Linear molecule, and it will be going in this way, and it will be going in this way. So it will be cancels each other, and here also the dipole moment will be equal to 0.
Then comes the
carbon dioxide. Carbon dioxide also this structure same concept. There is a linear structure. It having the dipole moment will be equal to 0. And 1,4-dichlorobenzene. Actually, this 1,4-dichlorobenzene is para condition. The para concept also, the dipole moment will be equal to symmetry. Yeah. So we can say here the dipole moment will be also equal to 0. So all this, the fourth one, that is the boron trifluoride, beryllium difluoride, carbon dioxide, 1,4-dichlorobenzene. All these concepts will having a dipole moment that will be equal to 0. So now you got the concept of this question. So sir, we can move to our next question.
Option 4 will be the answer.
Yeah, option 4 will be the answer. That is, we neglected already the first 3 options, and we can go through it. 4 will be the right answer of this question. So when we are moving further, what is the change in the oxidation number of carbon in the following reaction? This is a very simple question, and this question is directly based on our chapter, that is redox reaction. So we can say the oxidation number, this is a molecule, and you have to find the oxidation number of carbon only. Here the hydrogen having +1, so I'm just putting here that is X. So we can write here that is X plus 4 will be equal to 0. Therefore X will be equal to -4. And here if this carbon having -4 will be their oxidation state. And for this carbon, this is -1, and this will be +4 will be their oxidation state.
That's it.
So the initial carbon, the left side, in the reactant side, it is -4 is the oxidation state, and in the product side, it is +4 is the oxidation state. Therefore, the change is from -4 to +4 will be the answer. And here you got the answer very clearly. It is -4 to +4 will be their oxidation state.
It's a very direct question.
It's a very direct question, even though I think so the 10th standard students also we can do this.
This is the base of like redox reaction.
Basics of redox reaction. So even though any students that know the basic concept of redox reaction can do this.
They just want to know how to assign the oxidation number.
Yeah,
that's it. Actually, we are not using the concept of oxidation, reduction. Even they didn't ask a question to balance.
Yeah, sure.
Normally, if they are used to get questions like how to balance a redox reaction or to calculate the stoichiometric values. Such questions used to come. But this time it's very easy.
And based on the n factor also, the last time also the question is coming. And in this year, we cannot see that type of a question. And this is simple question. And we never expect this type of a question in this year also.
Sometimes it's go very simple.
Yeah, sometimes it will go for very simple concepts. So we can go through our next question.
We'll go on to the next question.
Actually, this question, when we are going to this question, actually it's a match the following type of question. And in this question, you are given by carbon monoxide, barium oxide, alumina, and the oxides of chlorine that is given here. And when we are going to the concept here, that is the carbon monoxide. That is the carbon monoxide, we can say carbon monoxide will be act as both acidic and it will be both basic also. It can be neither, that is, I can be act as both acidic and basic. So I can say it is we can say here it is neutral in nature. It can be neither acidic nor basic. It will be neutral in nature. And in the case of barium oxide, barium is a concept that will become basic in nature. That is metal oxides. Metal oxides will be always basic in nature. And the case of alumina, Al2O3, alumina, that will be, we already studying the concepts in the P block chapter. That is the P block 13th group. The 13th group, we are having the boron family. We have the elements boron, aluminium, gallium, indium, thallium. We study the oxides of alumina, that is amphoteric in nature. And the chlorine is a non-metal. The oxide of non-metal should be always acidic in nature. So what will be the correct answer? Here, see here, A42, A will be 2. So check it.
You have only one option.
Yeah, you're having only one option with the A.
Even with the first option, they'll be getting the answer.
Yeah, with the very first option, they will be getting the answer. And the B will be 1. So check the B will be 1. Yeah, same here. And the C will be 4. C will be 4, that is amphoteric. And the D will be 3. Actually, this is 3 the number. Actually, it's a wrong thing is happening here. So we can say here that will be the 2 will be the answer of this question. And actually, sir, this question if you the students know the concepts of the,
That's
even
it.
though we
They-
can
they-
say
they want
in
to know the
classification of elements also,
Yeah.
we are doing the concept that is the metal oxides, they are always basic in nature,
Yeah, that's
and if it is non-metal oxides, we are acidic in nature, and if it is amphoteric oxides, that is we can say metalloids are amphoteric in nature. That the normal concept we are studying here.
And I think this is the second match the following type question.
The second match of the
Yeah.
following type question, and so we can move through
Yeah,
our
we'll go to the
next
next
question.
question.
Okay, fine. So see here, students, based on this question, actually we can give this question as the question of both the chapters of P block and environmental chemistry. In P block and environmental chemistry, the same concept is explaining. You will definitely get, before I'm explaining this question, what the concept is given that in the P block and even though in the environmental chemistry. So when we are going to the question, which of the following is not correct about the carbon monoxide? That's the question is given here. Actually, which of the following is not correct? So it is it form carboxyhemoglobin. We know that concept, especially in the case of cigarette smokers.
Yeah.
If they are they're taking carbon monoxide, the carbon monoxide, that is, we can say the carbon monoxide reacted with the hemoglobin, that is Hb, it will form carboxyhemoglobin, and we studied the concept that carboxyhemoglobin is 300 times more stable, 300 times more stable than that of oxyhemoglobin. So here it form carboxyhemoglobin. That's the concept is right. This is right. This is the right option. That is, it will form
Yeah,
carboxyhemoglobin.
they're asking for the incorrect one.
Yeah, that asking for the incorrect concept. This is the right concept. It reduces oxygen carrying ability of the blood. It reduces the oxygen carrying ability. That is right, because they become carboxyhemoglobin. It reduces the oxygen carrying capacity. We studied that carboxyhemoglobin is 300 times more stable, and you know that concept very clearly. And when the carbon monoxide level in our body increases more than a particular limit, it will leads to a disease, that is a death due to anoxia, that is due to lack of death, that is lack of oxygen. Lack of oxygen will lead to anoxia. So we can say it reduces the oxygen carrying capacity. That is also a right option. That is also a right condition is given here. The carboxyhemoglobin, the hemoglobin bound to carbon monoxide, is less stable than oxyhemoglobin. I gave you the concept that is carboxyhemoglobin is 300 times more stable than oxyhemoglobin. So this is a wrong statement, and the wrong statement is the right answer for here. The wrong statement is the right answer for here. We have to find the that is not correct, that is incorrect concept. This is incorrect concept, and we can show it is produced due to incomplete combustion. This is a normal concept. If there is a complete combustion, it will form carbon dioxide, and incomplete combustion, it will form carbon monoxide. That's a normal concept that you already knows.
And also, so one more thing, in the question paper, this note is given in bold letters.
Yeah.
So that even the students will not get confused.
Yeah.
Normally they'll get which is the identify the correct statement. So it's very
actually
clear.
that moment is very important.
Yeah.
That moment when you realize the question, reading the question is initially, that's a very important.
Yeah, in that pressure, sometimes the students will get confused.
Yeah, sure. Actually, that time, even though every student's having a little pressure and anxiety and everything, when you control that emotions, you will definitely you will get I think out of 180 questions, most probably in the bio questions, the majority are based on our NCERT itself. So we can say 85 plus can be getting from the biology for a normal students also.
Definitely.
And the case of chemistry, I can assure that 43 plus. 43 plus
sure.
is sure for all the students. Even though in the ongoing batches also, they will get 43 plus for the.
I think I expect this time more marks.
Yeah, and the cutoff will be more, I think, this year.
Definitely.
And it will be I think we can be in between 620 to 640. 640 will be the cutoff marks. So we can go to our next question. So the next question, measuring the zeta potential useful in determining the property of colloidal solution. Actually, this is a question that is based on the chapter that is surface chemistry. In the case of a zeta potential, there will be two charges will be present. There will be two charges, that is inside you having that is forming a Helmholtz double layer.
Yeah.
It having a positive charge, and they will be also having a negative charge. There will be a double layer is forming of a positive charge and negative charge, and the two different charges, they will be attract together and they will be more stable. So we can say here the concept that is stability of the colloidal particles. The measuring of zeta potential is used to determine which property it will determine the stability of the particle. It's a very conceptual question that is
That's
given.
it.
That is a conceptual question is based on the chapter that is surface chemistry. Surface chemistry.
It comes in the properties of colloidal particles.
Yeah.
Like charge on colloidal.
Charge on
particles.
colloidal particles.
Where they are dealing with the Hardy-Schulze rule.
Yeah,
and
Hardy.
something
Yeah,
related.
fine. So we can go through our.
We'll go to the next
question.
Now, which of the following is the correct order of increasing field strength of ligands to form coordination compounds? So it's a very direct question because it's there. It's given in the textbook itself, like the increasing order of the field strength.
Increasing.
Yeah. I think in the page number 258, it's clearly mentioned. The increasing order of the field strength of different ligands.
SCN in that level.
That's it. So the order of the increasing field strength is something like I minus less than Br minus, then Scn minus, Cl minus, S2 minus, F minus, OH minus, then C2O4 minus oxalate, then we have H2O, then we have EDTF4 minus, then they're speaking about Scn minus, so it's already K. Then we have NH3. Then like ethylene diamine, then Cn minus and CO. Now this is the correct sequence.
Yeah.
So we have a shortcut tool, and but I think we don't want to reveal the shortcut now.
Okay, fine.
Okay.
And we can go through, and if the students join the next year,
Yeah,
so you can give them the shortcuts.
We'll give the shortcut how to learn this sequence.
Yeah.
Okay.
And also, students, when the case of the P block, I'm going with the P block, actually the inorganic chemistry. There is a code to study everything.
Yeah.
So for example, when you are going to the each elements and everything, there is a simple codes. Even though in the first S block also, hey, hello, listen, BBC News in the same level.
That's it.
That's a
There should be something.
Yeah. Actually, the coding method is a very important to study the concepts very clearly. And here the other is also a code to find the concepts and everything. So which will be the?
So now we'll take, they have asked about Scn minus, thiocyanate. So Scn minus. Okay, the first one is. Then we have F minus.
Yeah.
Okay.
Second one.
Then we have
oxalate.
C2O4 minus, oxalate.
Okay.
Then finally Cn minus. So the correct option will be Scn minus less than F minus less than C2O4 minus less than Cn minus.
So it will
option
be A will be the
correct
answer for that one. Okay.
And also students, they might be knowing like Cn minus, it's a strong field ligand.
Yeah. Always we are studying that concept in that chapter. That is
because they should know in order to identify the splitting. The splitting level, they should know whether it is a strong ligand or weak ligand. So Cn minus, CO, then ethylene diamine, NH3, all these are strong ligands. So definitely Cn minus will not come inside.
Okay, yeah, that is
like
oxalate,
oxalate, or oxalate like having higher energy. So
and here there is a little small twisting. That's twisting of the first two concepts, Scn and F minus. Sometimes the students will just confuse.
So it's also like it's near to the answer.
Yeah, near to the answer.
Very small difference.
Some students definitely they will be bubbled to this one also.
So it's a wrong option.
Wrong option, and the very right answer is the first one.
I minus, Br minus, Scn minus. So it will go like that.
Okay, fine. Okay.
So
we can go through our next question, sir. We can go through our next question. Actually, see here the question: elimination reaction of 2-bromopentane to pent2-ene. You are given by 2-bromopentane. So you are given by a aliphatic haloalkane. So the haloalkane that is converted into that is pent2-ene. So for example, see here 2-bromopentane. So we can write here that is CH3, CH here there is a Br, then it is CH2, then it is CH2, then it is CH3. This is 2-bromopentane. And this 2-bromopentane, that is the Br from here, and according to the Setzeff rule, the hydrogen from here will be eliminated. That is the HBr will be eliminated.
So they have two options to eliminate the hydrogen.
Yeah, two options. Either we can eliminate from here, either you can eliminate from this side. So here, according to Setzeff rule, we can select the that is hydrogen from this side.
Yes.
Okay.
So they can take now. This is the right one.
Right answer. Yeah. That is also a right answer. Okay. And this is we can say that is the HBr is eliminated. Yeah. So we can say this is a dehydrohalogenation.
That also will be the right
answer. And this is what is we are eliminating from the beta carbon. So we can say this is also a beta elimination reaction. So we can say here the answer that is beta elimination reaction is right. that follows Setzeff rule is right, and it is dehydrohalogenation reaction is also right. There is A, B, C, both the three concepts are right, and the correct answer, that will be 1 will be the correct answer for this question. Is that clear of all the students? Sir, and also this question is also not much a great task.
No, it's like it comes in their alkyl halides and aryl halides.
Yeah.
Because they are studying that Setzeff rule.
Yeah, and also see here, when we are removing this hydrogen and bromine, it will become, that is pent to
Alkene.
Yeah, that is alkene will be forming here. That is double bond is coming here.
Yeah,
will become CH2.
Yeah, here it will be CH.
Okay, fine. Okay, it will be CH. Then it will become CH2, CH3. So
it's it's also a very direct question.
Direct question. Okay, fine. So we can go through the next question, sir.
So it's from Thermodynamics. So the correct option for free expansion of an ideal gas under adiabatic condition, and everyone knows, because the work done during free expansion will be zero. So we have two options, like option 1 and option 3, because work is 0.
Here the work done is 0, and here the work done is 0. But here you have to look the concept of adiabatic. The adiabatic condition is very important. In the case of adiabatic condition, the heat change, that the heat will be always equal to 0. So what will be the answer? The work done should be 0, and the heat change will be equal to 0. So we can go through the first answer. Is that right, sir?
First answer.
Yeah, fine. So we can go through the first one. The first one will be the right answer for that question. So I think so we can go through our next question.
Okay, sir, please.
So identify the incorrect statement. You have to find the you have to identify the incorrect.
This is the fourth question related to correct and
incorrect statement, I think. So we can say you have to find the incorrect statement. Chromium 2 plus with having the D4 is a strong reducing agent than Fe2 plus in D6 in water. There is a chromium. We ordered this. Actually, it's a direct concept that is given in our chapter. That is D and F block elements. Actually, in D and F block elements, it is given that the D4, that is the chromium 2 plus, is a strong reducing agent, and it is already given that is due to its ability to form D5 configuration. It have a tendency. Yeah, it have a tendency to become, that is a half-filled electron configuration. It have more reducing property. So we can say it is a more reducing agent than Fe2 plus. So this concept is right. The transition metals and their compound are known for their catalytic activity due to their ability to adopt multiple oxidation state and to form the complexes. Actually, the D block elements, it is a characteristics property of a D block element, that is variable oxidation state, magnetic property, for then in the tendency to form interstitial compound, then they can form complex compound, tendency to form alloys, paramagnetism. That is the common characteristics property of a D block element. So we can directly go here. They are having multiple oxidation state, that is variable oxidation state. And the case of, we can see, when the case of 3D series, when you're going to the 3D series, we are studying, it have a +2 is the common oxidation state. And even though when we are taking the classes, we define that very clearly. That is, it have a common oxidation state of +2, and they will, manganese will show.
Then it get gradually, that will increase up to manganese.
Manganese will show +7. And osmium and ruthenium, these are the two elements, that is osmium and ruthenium are the two elements. They will show an oxidation state of +8. That osmium is showing that +8 electron configuration in the compound OSO4, and ruthenium shows +8 oxidation state in the compound, it will show in the oxidation state in the compound RuO4. It will be RuO4. In these two oxidation state, they will show this +8 oxidation state. So see here, this is, we can say, that is, these are the concept. I'm just going through the concept clearly, that is related to the T block.
And this is also the right.
Yeah, this is also a right concept. Actually, I was going through the detail into this concept. Interstitial compound are those which formed to these small atoms like hydrogen, carbon, nitrogen are trapped inside a crystal. That is known as interstitial compound. And we studied the properties of interstitial compound. They are hard, they are rigid, and they have a high melting point and boiling point. That are the concepts we are studying. The
features of interstitial compound. And I think this definition, this is given in the textbook.
They directly is
it's a direct
definition is given here. And the oxidation state of chromium O4 minus, that is CrO4 minus, is given here. So I'm just putting here chromium is X, and the oxygen having the -2 here. So we can write here that is X minus 8 is equal to -2. x minus, this is minus 2 into 4, it will be equal to minus 8. That will be equal to, there is a charge is given here, that is minus 2.
Yeah.
So we can write that is x is equal to minus 2 plus 8, it will be equal to plus 6 is their oxidation state.
So in chromate it will be plus 6.
Plus 6. So you can do this, the Cr2O7 minus.
So in Cr2O7 2 minus, Cr2O7 2 minus dichromate ion.
Yeah.
So we'll take x for chromium. So you are having 2 chromium, so we'll give 2x. Now O7. So 7 into minus 2 minus 14. That's equal to the net charge. That's equal to minus 2.
Okay.
So they'll get like 2x equal to minus 2 plus 14, 12.
Yeah.
Or x is equal to plus 6.
Yeah, that is 12 by 2.
Yeah.
It will be equal to plus 6.
So
That is both the concept. Here they're having the same oxidation state of plus 6. Here in this case of a chromate, that is plus 6, and here also it is in the plus 6 condition.
It's the highest oxidation state of
chromium.
Yeah.
And also here that is showing they are not same. Actually they are same.
They are same.
I think you got the concept.
That's the answer.
Actually, it's if you know the chapters very well, definitely you can crack the 2020 NEET exam.
Definitely.
And even also the 2019 also. This I think this much not easy in the 2019.
This time it's clearly NCERT based.
Yeah, clearly NCERT based and clearly simple concepts.
Simple NCERT we can say.
Simple NCERT concepts is given here. And also for the CBSE exam, I think little bit task thing.
Yeah.
Little bit more tough for the
Yeah.
CBSE exam, final exams. So
and
when
also let's see, the incorrect is given in bold letters.
Yeah, sure. That in the question that is given, that is incorrect statement is given in that bold letters. So we can go through.
We'll go to the
next question.
That also of the same kind.
Yeah. Actually, this is a question that is based on a table that is given in our chapter, that is classification of elements. Actually, see here, there is unyl unium, that is 101.
Yeah,
Unyl unium means that will be equal to 101. Actually, it is also known as Mendelevium that we are studying in the chapter, that is classification of elements and their periodicity. And the case of unyl trium means 103. This is also known as Laurentium. 103, that is also known as Laurentium. And if it is non-nil hexium, that is 106, that is known as a Seaborgium. And if it is unium, that is means unium, that is 111, that is known as the Dermastadium. It is also known as another name. So this is known as actually the wrong. This is wrong is given here. This is actually
that will be the wrong match.
Wrong one. Actually, Dermastadium is not there. It is known as Rhontangium. It is known as a Rhontangium is the right answer. We can say here that it is known as a Rhontangium will be the right one. Actually, the unium, that is the 111, it is actually known as a Rhontangium. Actually, this is a question that is based on a table. Actually, it is based on a table that is given in our classification of elements and periodicity chapter. So that is, I think, sir, it is just after the 3 pages when you started the
nomenclature
chapter.
of those elements.
Yeah, nomenclature
more than 100.
Greater than 100.
Yeah.
When you are doing the nomenclature greater than 100, you are studying the concept. If it is millium, and up to 118 is given. Up to 100 to 118 is given.
But I think students will not take care of this.
Yeah, this concept. But here, see, the question is coming from a single concept or a single table that is related to our NCERT. Okay, so I think so we can go through.
We'll move to the
next question. Actually, what will be the answer for that question? So actually, we can say that is the fourth one. The D, that is the 4, that is the incorrect statement. Yeah. Actually, this is not Dermastadium. It is actually Rhontangium. Yeah. So for the fourth one will be
that will be the wrong option.
Wrong option. Okay, fine. So we can go through the next one.
So reaction between benzaldehyde and acetophenone in presence of dilute NaOH. In presence of dilute NaOH. So definitely it will be something related to aldol condensation. Dilute NaOH, right? So they have given like aldol condensation, Cannizzaro reaction, cross Cannizzaro reaction, and cross aldol condensation. So in aldehydes and ketones, though they are learning like aldol condensation, they are learning Cannizzaro reaction, and also they are learning about cross aldol condensation. They are not going through cross Cannizzaro reaction.
Okay.
So anyhow, we are taking 2 different aldehydes. Like we are taking benzaldehyde and acetophenone. So definitely since we are taking 2 different aldehydes, it will be like cross aldol condensation. Anyhow, we'll go for the reaction.
Okay.
So reaction between benzaldehyde. So this is C6.
Yeah, benzene ring with the CHO.
CHO.
Okay.
CHO. So I'll write like C double bond OH.
Okay, fine. Benzaldehyde.
Yeah. Plus then acetophenone. Acetophenone will be C6H5 COCH.
COCH.
So I'll write from here C6H5 C double bond O CH3. Now those carbon atom or with those which are having an alpha hydrogen atom. So we like this hydrogen atom will be placed to this oxygen and we'll be having a co-product something like COH, then CH here, double bond or single bond CH2, CO
and benzene.
Yeah, and benzene.
So benzophenone.
So you'll be getting something like that, and now we need to eliminate this OH and the hydrogen, beta hydrogen from here.
Yeah.
So we'll go for an elimination by while heating.
Okay,
so
fine.
we'll be getting the final product something like.
I'm saying the final product here.
Yeah.
By elimination.
Yeah. CH double bond CH CO C6H5. So this reaction, I think this reaction is clearly mentioned in the textbook. Same reaction like between benzaldehyde and acetophenone. It's given in the textbook.
Okay.
So this reaction is known as like cross-aldol condensation because we are taking different aldehyde or different like two different species, one aldehyde and one ketone. So since we are taking different aldehydes and different ketones, such reactions are called cross-aldol condensation.
Okay.
So if it is between same aldehydes, it's called aldol condensation.
And if it is different, if it is different, it is known as the cross-aldol condensation. So we can move to the next question. Actually, the next question, we can go through the question. Which of the following oxo acid of sulfur having OO, that is oxygen-oxygen linkage? Actually, students, you can search the chapter that is the P block second year. The P block second year, that is the group 15. When you are studying the group 15, and you can search the page number 194. You can see here that is the H2S2O7. H2S2. So here, sorry, this is H2S2O8.
Yeah,
this is H2S2O8.
And also it will be in group 16.
Yeah,
sulfur,
that is oxygen sulfur.
Oxygen.
Okay, fine. That is not group 15. It is group 16. Oxygen sulfur. That is the
group 15. That
group 15.
Chalcogens.
The chalcogens we are using here. So here there is H2S2O8, that is known as the peroxide disulfuric acid. They're having an oxygen-oxygen linkage.
Peroxide linkage.
Peroxide linkage will be there, and that's a simple concept, I think.
And normally
we are studying that oxo acids, we are studying that clearly, and if they know that oxo acids very clearly, they can find this answer, that is H2S8.
Because this is also a question that something they get confused in order to calculate the oxidation state of sulfur.
Yeah.
Because if they are calculating, they'll end with a result of +7.
+7.
Yeah. Because they don't know like oxygen single bond oxygen. We have to consider -1 for oxygen. So that's this concept is studied in redox reactions also.
Your redox reaction also we have discussed this concept.
So it is having like SOOS bond. SOOS bond. Okay. So in H2S2O7 that will be SOS bond. Okay, so their answer will be peroxodisulfuric.
Peroxodisulfuric
acid. Very direct question.
That is H2S2O8. H2S2O8 will be the right answer for that question. So we can move to our next question.
Next one.
HCl is passed through CaCl to MgCl to NaCl. And which of the following compounds is crystallized? Which of the following compound is crystallized? That is the question is given here. And we know that there is only one compound crystallized, and that one compound is known as sodium chloride, that is known as the common salt. The sodium chloride, so we can say the sodium chloride is also known as the common salt, and which is the only compound that will be undergo crystallization.
When HCl comes, that NaCl will come out.
Yeah. So it is the only process of crystallization.
Purification of NaCl.
Yeah, purification of NaCl. We can say extraction of NaCl. We can say most probably you can say the extraction of NaCl. And here in some processes we are using that is CaF2, that is KCl to reduce the melting point of the NaCl and everything. We are studying the chapter detailedly. That is S block elements.
Yeah, because if MgCl2 or if present along with NaCl, it will be little deliquescent in nature. Yeah, so in order to have that property, like we'll eliminate that MgCl2. So our laboratory grade NaCl, which is free from other sort of impurities. We are going for this method.
Okay, fine. So here we got a solid, that is a crystal out, that is known as the NaCl.
NaCl, sodium. It's a pure sodium chloride.
Yeah, pure sodium chloride. So we can go to our next question. And in this question, you are given by anisole, so you can go through this one.
Anisole on cleavage with hydrogen iodide.
Mhm.
So it's a reaction between anisole, like an ether, and hydrogen iodide. So the reaction C6H5 OCH3 plus HI. Now the students have to decide whether this bond break or this one, or one or two. So
What
we
is
are
the answer?
because see, we know that like something bonded with benzene ring, they'll have a partial double bond character, and it is bonded to an sp2 hybridized carbon atom. Then difference in the electronegativity. So it will be very difficult to break that bond. So definitely the bond between oxygen and alkyl, that will be very easy to break. So once the bond is break, we'll be getting,
that is will become
that
O will be there.
O will be there, and H will go to that one.
So it will become phenol.
This H will be moved to this one, and we'll be getting an alkyl
iodomethane,
Ca3.
Yeah, fine.
So this will be the product.
So it will become phenol and iodomethane. So the answer here will be, what will be the answer here, the students? Here it will form phenol and the iodomethane. That is A will be the answer for this question. And actually this question is also a very simple concept. Actually this is also, I never see the organic chemistry which is such a simple type of a question here.
This question comes in +2 for the conversion.
Convert
anisole to phenol.
Yeah.
It's a conversion coming in that section. But I think some students might have written this answer also. Like instead of breaking the bond here, they might
they will think to break the bond like here. Okay. Actually, it is not going to happen now.
Anyhow, the question, the answer will be option 1.
Option A will be the answer. That is, will form phenol and the iodomethane.
Okay.
So we can go to our next question. Okay. So based on the next question, identify the correct statement from the following.
I think this is the 6th or 7th question related to correct and wrong statement.
That is the incorrect statement. Yes. Actually, in this question, it was given there that is CO2 gas is used as a refrigerant of ice cream and frozen fruit. See here, students, this G is a concept, that is the only concept that is make this answer is a wrong one.
That's it.
Because the solid carbon dioxide, we can say solid carbon dioxide, that is known as dry ice. The dry ice is used as a refrigerant. It is used as a refrigerant like Freon. We are using the same form, that is a solid carbon dioxide, that is known as dry ice. It is used as a refrigerant for the ice cream and frozen food. So the first one itself is a wrong statement.
Not the gaseous carbon dioxide.
Yeah, not the gaseous carbon dioxide.
Gaseous carbon dioxide is a greenhouse gas.
Greenhouse gas also. And also the second one, actually it is a Buckminster Fullerene is given here.
C60.
That is C60. Actually, definitely the students will think that it is the right one, because they just go through the concepts only. That is the same thing when you are going through the vocabulary. Actually, it is given that is 12. And it is
20.
given that is 20.
Yeah, that's it.
Actually, it is not 12. It is 26 carbon ring. Actually, it is 26. That is 20 hexagonal ring is forming there.
26 membered ring.
20 hexagonal ring, and it will form, that is 12 pentagonal ring is also forming there. So it is having 20 hexagonal rings and the 12 pentagonal rings. Therefore, this concept is also wrong. So we already studied in the last part of zeolite. That is sodium aluminosilicate, that is known as the zeolite. ZSM5, that is you are studying that same concept in P block. That P block first year, group 14, the end part after the silicate. After the silicate, we are studying that zeolites.
And also it comes in surface chemistry also.
Shape
selective catalysis.
Yeah, shape selective catalysis, we are using that. So zeolite, ZSM5 is a type of zeolite is used to convert alcohol into gasoline. The same paragraph, the same word you can see in that P block chapter also. And also see for the we can go through the fourth one. Carbon monoxide is a neutral gas. We already discussed that type of a question. And it is a colorless and it is a odorless in nature. So what will be the correct answer for that one? I think it will be, there is a C is right and the D is right. So we can say the C and D is right only here. So the fourth
option.
Yeah, fourth one will be the right answer for this question.
Very direct question.
Yeah, it's a very direct question. And so we can go through our next question here.
So that comes from thermodynamics.
Yeah.
So
actually this is the second question, I think, from
thermodynamics.
Thermodynamics. Okay, fine.
So they are like a reaction that chlorine atoms getting converted to chlorine molecule. So we know that like when chlorine is more stable than Cl.
Yeah.
So that the energy will be lowered.
That is okay, fine. Yeah.
That means when Cl is getting converted to Cl2, that will become more stable and the energy will be given out.
Okay.
Energy will be given out means delta H will be negative.
Delta H will be negative.
So delta H will be like less than 0. I can say like delta H, or the process is exothermic or less than 0.
So it can be either 3 or it can be either 4. Sir.
Yeah, with either 3 or 4. Then like if you go for the entropy,
that is the atom is converted into molecule. Okay, fine.
So Cl that like it will be having more entropy, or that enjoys more entropy than Cl2.
Okay, fine.
So Cl2 is something restricted. Cl single bond Cl. But Cl we are having 2 chlorine atoms, so they are free to move. So they don't have any restrictions. But when it is combined to form a single molecule, its entropy will be decreased.
Okay.
Okay, so when entropy is decreased, that means delta S will be negative or less than 0. So the answer is both delta H and delta S will be less than 0.
Less than 0 will be there.
So delta H less than 0 and delta S less than 0.
So I think that the fourth one will be the right answer for this question. That is delta H, that is the enthalpy of reaction is 0 and the entropy of the reaction is also 0. So the both concept will be 0. Actually, if they know the concepts clearly and they have to check this concept. This is atomic chlorine and this is the molecular chlorine. That's the concept is changing here. Actually, so we can go through our next question. Actually, this question, paper chromatography, is an example of. See here, students, when you are going to the chapter of surface chemistry, in the chapter of in the chapter
organic 1 plus 1.
Yeah, organic, not in the surface chemistry. Actually, in surface chemistry also we are studying
adsorption. The principle of adsorption is our surface chemistry.
Okay. Actually, when we are going to the organic chemistry in the grade 11 organic chemistry, that part 2 textbook. In that part 2 textbook, when we are going to the last part of that is Leisinge test, chromatography, there you can see paper chromatography, that is then gas chromatography, then partition chromatography, then adsorption chromatography. There is different types
of techniques. The basic principles and techniques comes in this section.
This sides, that is the question is coming. Actually, the adsorption chromatography is the main heading, and the partition chromatography, thin layer chromatography, column chromatography will be come under behind that same single heading.
Everything is given in that part.
Yeah. And the paper chromatography is an example of. That's the question is given here. That is the paper chromatography is an example of. When we are going to that concept, when you can check the I think the number here is about 353, I think the page number in that organic chemistry, in the page number 353, there you can see there is partition chromatography. When we are going through the partition chromatography, you can see here the same concept, that is paper chromatography is an example of a type of partition chromatography. And even though
the same sentence is there.
Yeah, the same sentence is there, and you know what is in by chromatography. There is the adsorption concept and the adsorption on the adsorbate. The adsorption on the adsorbate, and you are studying the chromatography in this chapter, that is organic chemistry, and a small concept in surface chemistry and a small concept in metallurgy also. That is a refining process. In the final process, we are studying chromatographic method. We are also studying there. So we can
move on to the next
question.
So the answer for this one is option.
That is the partition chromatography. So we can say second one will be the right answer for that one.
Now, which of the following alkane cannot be in good yield by Wood's reaction?
Actually, it is given that is good yield.
Yeah, that good yield is important.
And so also it is Wood's reaction.
Everything will be produced, but we need to know which reactant or which product will be in good yield.
Okay, actually, according to Wood's reaction, it is Rx plus 2Na. Yeah. I'm just writing here 2Na plus XR. It will become RR. RR plus 2NaX. This is a normal, that is known as the Wood's reaction. This is known as the Wood's reaction. So this Wood reaction is most, you can say.
Yeah, we'll be getting like RR, even number of carbon atoms. Even number of carbon atoms to prepare.
Yeah.
Like we'll be getting ethane, then
butane, hexane, octane.
Likewise. So for N-hexane, it's possible. Like we have to take propane. We'll take like chloropropane, bromopropane, etc. That it can be converted to hexane very easily, because 3 carbon atom can be converted to 6 carbon atom. 2,3-dimethyl butane also is very easy to prepare. Like we are having even number of carbon atoms. In N-heptane, they are having 7 carbon atoms. And as per the method, we should get a reaction with 3.5 carbon atoms. Like
Okay.
Wood's reaction will be like, it will just double the number of carbon atoms. We have some other methods, like we can take different alkyl halides.
Okay.
So if you want to prepare heptane, we can take an alkyl halide like 3 carbon atoms with 4 carbon atoms.
That is,
but
you can take
your yield
propane,
will not be in good.
Propane, and you can take butane.
Yeah, propane and butane. So your product will be like a mixture of alkanes will be.
So we can say, sir, you are saying like that you can either choose that is halopropane and with the 2 Na with that is halobutane.
Yeah, you can. It's possible. But the thing is that we will not be getting N-heptane alone.
Yeah.
You'll be getting a mixture of products.
Yeah.
And one of the product will be N-heptane. But the
Okay.
question is,
The good yield.
yeah, the good yield.
Actually, that's the question. That is a good yield.
Yeah.
To get a good yield, you have to get an even number.
Yeah.
The even number is the concept here. The even number will be getting a good yield, and always
Because
the
there
Woods,
will be the single product.
yeah. In the case of a Woods reaction, it have a most probability or most priority to get a
Yeah.
good yield. So here the answer which cannot be made a good yield, that is
Because
N-heptane.
the N-hexane comes as a single product.
Mhm.
2,3-dimethyl butane. We can get a single product.
That is butane is
yeah.
coming.
Yeah, because it's able to, we will be able to get a single product like 2,3-dimethyl butane.
Mhm.
But N-heptane always come along with a mixture of other products.
Okay, fine.
So that the product that N-heptane will not be in good yield.
Okay.
Because that will be like 50% or 40%, something that. But all other will be 100%.
Okay.
So yeah, N-butane also is possible. Like we can take 2 carbon atoms.
2 carbon
so you'll be
atoms.
getting N-butane like 100% yield. So the answer will be N-heptane. Anyhow, you'll be getting N-heptane, but that will not be in good yield.
Good yield. Okay, fine.
That's it.
So we can go
Yeah.
through our
Next
next
question.
question. That
Next
is question number 33, I think. So
Yeah.
as increase in the concentration of the reactants
yeah.
reactants of a reaction leads to the change in. Actually, this is a direct definition that is based on the chapter that is chemical kinetics.
Chemical kinetics.
Chemical
So the
kinetics.
second question from chemical kinetics. One is
Yeah.
to calculate the time.
Yeah, that T is equal to
T is equal,
2.303
yeah.
log.
So you got
yeah.
2 questions from chemical kinetics.
Yeah, fine. Actually, from this chemical kinetics, this is the second question, and this is what is the concept here. The increase in the concentration of reactant of a reaction leads to the change in what? It leads to the change in
Collision frequency.
collision frequency. And does not the threshold energy. What is the threshold energy? It is the minimum energy required to liberate the electron. Actually, the threshold energy concept you are directly studying the chapter structure of atoms.
Structure of atom.
And a photoelectric effect, when a beam of light is falling to a metal surface, it suddenly ejects electron without any lag, and the frequency of light, it should having a minimum frequency that is
Because we
minimum.
can use this threshold in many concepts, like in terms of energy concept, in terms of reaction concept. Everywhere we can use this concept.
That is, and we are using that threshold
Yeah.
energy as mu
Yeah.
zero.
Yeah, mu zero. Yeah.
Mu zero is the value, and it does not the heat of that is
Enthalpy
activation.
of reaction.
Yeah.
It does not change because enthalpy of reaction will be same. Activation energy also, that will remain the same. And if the concentration is increased, that increase the crowdedness.
Mhm.
So it will be crowded.
Okay.
So the number of collisions per second will be increased. See, if you are having like a concentration of R, so there will be a specific amount of collision.
Mhm.
But if it is 2R, the more number of reactants, so the collision per second in a given volume will be definitely it will be increased.
Increases.
So it's called the collision frequency.
Okay.
Number of effective or the collisions per second in a given volume.
That is in at a particular second also.
Yeah, at a particular second.
Okay.
So that will definitely go to increase because we are anyhow the reactants, since it is increased, that will create a crowdedness.
Mhm.
So
Okay,
that
fine.
definitely that will increase the collision frequency also.
Okay,
So
fine.
it's a very direct question.
Okay, fine. So we can go through our next
The
question.
options.
Yeah, option that is the collision frequency. That is the 4 is the right
Right
answer.
answer.
So when we are going to our next question, the question is given the number of farad. That is a question. If it is a coming that farad, that is a we can see before the batteries.
Yeah.
That they lead storage battery and everything. There is a concept is purely given in the concept of farad with respect to the electrons.
Faraday's law.
Faraday's law
Yeah.
with respect to the electrons and everything. The number of farad required to produce 20 gram of calcium from molten CaCl2. We can write CaCl2. This calcium have a 2 plus is their oxidation.
Ca2 plus will be the oxidation state.
So Ca2 plus 2 electron will give us a Ca.
Ca.
So
Now-
here it having the 2 electron. This 2 electron means it having 2 farad. 2 electrons
2
means
moles of electrons will carry a charge of 2 farad.
2 farad. And here this is for the atomic mass. Here it is 40.
Yeah, 40.
So for 40 gram it is 2 farad.
Yeah.
So for 20 gram, that is given in our question. For 20 gram, it will be equal to that is 2 by we can say here
Just
that is
half the value.
just
of 2
half the
farad.
value. It will be equal to 1 farad. That's a simple concept.
Yeah, so in order to produce 40 gram of calcium, we require 2 farad of electricity. Yeah, so that instead of 40, then if we want 20, that means the half of that 2. That will be like 1 farad.
1 farad.
So very direct question.
Very direct question. We can do that. So we can.
So the answer will be.
The answer will be
option
one will be the
option
right
one will be
answer.
the right
One will
answer.
be the right answer. Students, please check your answers clearly. That go through the concepts clearly and check whether your concepts and your ideas is right or wrong. Okay, so we can go through
And
our
also the question booklet that we are discussing is E2.
E2. Yeah. We are discussing here the question booklet is based on.
So that question number will be based on that
the E2 level. So students, you have to check your questions according to that. Here we are discussing the questions based on the series that is E2 level.
Yeah.
So all of the students go through your questions. The same question is in a jumbled order will be given in the other series also. So I think we can go through the next one. So we can go through the next one.
So that comes from the chapter solutions.
Solution is the chapter.
Nothing to say, like mixture of which shows positive deviation from Raoult's law. So ethanol and acetone. So positive deviation means the molecule should find very easy to escape than in their pure state.
Okay.
So you know that ethanol is hydrogen bonded.
Yeah.
So
definitely it having
hydrogen bond will be there. So ethanol will find very difficult to escape in their pure state.
Yeah.
But when we are adding a bit of acetone, that hydrogen bond will be disturbed. So that ethanol molecule will find very easy to escape than in their pure state.
Okay.
So ethanol acetone, that mixture. In ethanol acetone mixture, the molecules of ethanol will find easy to escape than in their pure state.
Okay.
So that they show a high vapor pressure.
So I think this will be
that will be the answer.
Right,
that will be the right answer. So
actually,
they shows positive deviation.
Okay, fine.
Then benzene and toluene, they forms an ideal solution.
Okay.
Then acetone and chloroform. See, acetone means CH3COCH3.
Okay.
CH3, C double bond O, CH3.
Okay.
And we are taking like chloroform, like CHCl3.
Yeah.
CHCl3. So definitely a hydrogen bond will be created. So here hydrogen bond is destroyed and here hydrogen bond is created. So when a new hydrogen bond is formed, that molecule will find very difficult to escape. So that vapor pressure will be reduced. So that shows negative deviation.
Okay, fine.
And
so this will be the negative
deviation. And chloroethane and bromethane are example for ideal solution.
So the B, that is the second one, and the fourth one is an
ideal
concept.
Yeah.
Acetone and chloroform
they show negative deviation.
And those only one that show, actually this is a direct question.
Yeah, direct, because the example is given like
given in our NCERT itself.
Deviation.
Actually this is the ethanol and
there are two examples like ethanol and acetone and carbon disulfide.
Yeah.
For positive deviation.
Yeah,
so the right answer is option 1. Ethanol and acetone will show
ethanol and acetone will be the right answer for this question. So we can
we'll move on to the next one.
Next one, yeah.
So hydrolysis of sucrose is given by the following reaction. So everyone knows sucrose on hydrolysis will produce glucose and fructose. Now the equilibrium constant Kc is 2 into 10 to the power 13
at a
temperature of 300 Kelvin. Then the value of delta G0 at the same temperature, that means they need to calculate the standard Gibbs energy change. Yeah. So it's there in the thermodynamics, like the last part of that thermodynamics.
And also we can see the same reaction, that is we can use the delta G concept in the equilibrium also. With respect to the equilibrium also we are using with respect to the Kc
value. See, the Kc value is 2 into 10 to the power 13.
Yeah, provided. Actually it is given
in our... want to calculate the Kc value.
Yeah. Actually the Kc concept, that is a relation between equilibrium constant and Gibbs energy. Is given in our, actually it is after that is in, we can say it is chemical equilibrium. Not in the after physical we have the chemical and also we have the ionic equilibrium. Yeah. Just before the ionic equilibrium it was given in our NCERT, that is the relation between Kc and the delta G concept.
So we have the equation, we can apply the equation delta G0 is equal to minus RT natural logarithm of Kc.
Yeah.
That's the equation. And R is provided, we know the value of R. So delta G0 will be equal to minus 8.314 joule per Kelvin per mole. It's given 8.314 joule per Kelvin per mole into temperature is provided 300 into natural logarithm of the value of Kc is given 2 into 10 raised to 13. They don't want to solve this question, sir.
So direct one.
Yeah, then this is the answer. They don't
so
want
if
even,
the students know the equation, actually this same equation, I think in the thermodynamics, you can see the reaction at the end part, that is in the chapter page number in 180, I think.
Yeah.
Most probably
It's
in the
close
page
to-
number,
close to, yeah,
you
very,
close to
very-
that 180 or 180 or 185.
Yeah.
In that level, you can see this reaction, and the equilibrium also just after the just before the ionic equilibrium, you can see this reaction delta G0 is equal to minus RT ln Kc, that is natural logarithm
Yes,
Kc.
you know, actually we used to teach students like 8.314 into 300 is something close to 2500.
Yeah.
And because they don't want to go for such calculations also.
Uh-huh.
See, this 8.314 into 300 into natural logarithm of, if they want to calculate the correct result, they might have been troubled because they need to go to natural
logarithm concepts.
Then they need to convert to log, then 2.303 into log 2, even though they'll get the answer, but it will be a bit difficult for them.
Yeah. But this is there is no toughness. There is directly in that same level is the question is given here.
Yeah. So the answer will be like minus 8.314 into 300 into natural logarithm of 2 into 10 to the power 30.
So answer A will be the right answer for this question.
That's it.
Is that right, sir?
Yeah.
Okay. So I think we can go through our next question.
Next question.
So the next
Sir, please,
question.
please.
Okay, fine. Sucrose on hydrolysis. Actually, sucrose on hydrolysis inform glucose and fructose.
Definitely.
That we are studying in the chapter biomolecules.
The disaccharide.
Yeah, there is a chapter that we are studying in the chapter that is biomolecules, and for a NEET student, actually they are for a NEET student they are studying the biomolecules chapter in biology also, sir.
The process is called inversion.
Yeah, inversion configuration. Why it is known as an inversion configuration? Because this is dextrorotatory
Sucrose is
and the
dextrorotatory.
fructose is a more levorotatory, and the whole rotation will be levo rotation. Therefore, the whole will become inversion of configuration. This is known as inversion configuration. So see here, the sucrose and hydrolysis will be give alpha D glucose and beta D fructose, and it is just directly given in our NCERT.
So these are the hydrolysis product of sucrose.
Yeah, this is the hydrolysis product
Alpha
of
D glucose and beta
D
D
fructose.
Yeah.
So we can
we'll
go
move
through
to
our
the
next
next
question.
question.
Okay, fine.
So I think this is the last section.
Last section.
Yeah.
So
What
when
was-
we are
what was
going to
that?
the next question, see here, students. Calculate the spin only magnetic moment of a Cr2 plus, that is chromium 2 plus ion. You know that chromium, that is atomic number 24, that is we can say here that is argon, we can say that is 3d5, it is 4s1. This is right, sir?
Yeah, 3D4.
Argon
But
3D4.
some students may write like 3D4 4s2.
4s2.
Yeah.
But it is the actual based on their stability.
Yeah.
It is 3d5 4s1.
I think that's why they give this question.
Yeah,
CRT.
and it is 2 plus is given, that is the 2 electron is gone from this reaction. There is 1 electron from the 4s orbital and the 1 electron from the 3d orbital, and the answer here will be argon 3d4 4s0 will be the answer.
Yeah, that's it.
Is that
So,
right?
Yeah, they need to calculate the number of unpaired electrons now.
That is mu is equal to
Yeah. So 3d4 1 2 3 4. No sir, please go ahead. Please.
So see here, I can give a simple concept here. So if it is D1 or D9 orbital, if it is D1 and D9 orbital, if the magnetic moment is expressed in Bohr magneton. That is mu is equal to root of n into n plus 2. That's the equation. Mu is equal to root of n into n plus 2, and this is known as the magnetic moment, and this magnetic moment we are expressed in Bohr magneton. And for the students of mine, I am just using a just simple concept here, sir. For D1 and D9, I can give a magnetic moment.
D1 to D9 or D1 and D9?
D1 and D9,
D1 and
because
D9.
both of them having one unpaired
unpaired,
electrons. We can use the magnetic moment is equal to 1.73 Bohr magneton.
Okay.
And for D2 and D8, it will be equal to 2.84 Bohr magneton. And for D3 and D7, it will become 3.87 Bohr magneton. And if it is D4 and D6, it will be equal to 4.90 Bohr magneton. And if it is D10, that we can say, yeah, D5, so it will become 5.92 Bohr magneton. And in the case of D0 and D10, there is no unpaired electrons, therefore the magnetic moment will be equal to 0.
Zero Bohr magneton.
0 Bohr magneton. Actually, this is a very
So
simple.
if they know this calculation,
It's
will be
very easy.
for
That
them.
is, it is D4 here.
Yeah.
So for the D4, they got the concept. That is, it is 4.9.
Yeah, so they are having 4 unpaired electrons.
4 unpaired electrons. So those who are having the N is the unpaired electrons here. So that is this is the actual equation of finding the Bohr. That is
spin only formula.
Spin only formula. Yeah. This is a method of finding the magnetic moment.
So they can, if they want, they can directly they can apply like 4 into 4 plus 2.
4 plus 2.
So it will be like 24, root 24, something just less than root 25.
Root 25.
So
that is just
5.
less than 5.
Yeah. So
it will become 4.90.
Yeah,
so we get the correct answer here. That will be equal to 4.90 will be the correct answer for that one. Okay. And this is also a direct question.
Direct question, very direct question.
Very direct question. And there is no need of calculation here. And so we can go through our next question. And in this question, see here, students, which of the following is a natural polymer? Actually, see here, students, it is very clear from the example itself, the first one itself, that is isoprene, sir. That is the rubber. The rubber, we know that it is known as isoprene. And cis isoprene.
The basic unit of rubber.
Yeah, basic unit of rubber is cis isoprene. And it is given that is cis 1,4 polyisoprene.
Yeah.
That will be itself.
It's a cis isomer. It's a cis isomer.
Cis isomer. Yeah. That means that itself will be the natural polymer, because this is known as rubber. No need of going for further things, because it is directly we can say. And there is also a biodegradable polymers is also PHBV.
PHBV.
That is polyhydroxy beta. Then valerate. That is the concept of PHBV. So that PHBV is a biodegradable polymers. Nylon 2, nylon 6 is a type of a biodegradable polymer. And here that is the natural.
About the natural polymer.
Yeah, natural polymer. This is not a synthetic polymer. And here there is asking the natural polymer. The natural polymer, we can give the very common example that is known as the rubber. And you studied that concept of rubber, vulcanization of rubber, and the reactions and everything in the chapter
it's actually rubber only, sir.
Yeah, right. Yeah, there is no need of explanation of that things.
It's so, like poly cis 1,4 isoprene.
So what we can go through, one will be the right answer for that question. So
now we'll go for the next question.
Next question, and we can go through that question.
So which of the following is a basic amino acid? Okay. So they have given some examples like serine, alanine, tyrosine, lysine, etc.
Okay.
So we know that like a basic amino acid will have more amino groups than the acidic one.
Okay.
So we have like it's a classification based on basic amino acid, neutral amino acid, and acidic amino acid. So an amino acid can be generally it can be represented as R, CH, NH2, COOH. Now this is the general representation of an amino acid. This is an alpha amino acid. Now here the R decides whether it is neutral or it is acidic or whether it is basic. If R has more number of NH2, because here we are having one NH2 and one COOH.
So we can generally say there is itself it having an NH2 group.
Yeah.
So it will be having a little bit basic character.
Yeah.
So if the number of amino group increases the basic character will be very high.
So we should know how many or what is the R in serine. Okay. Now if you go for serine, the R part, the alkyl part will be like OH CH2.
Okay.
Okay. Now if we club this OH CH2 here, we don't have any extra COH or extra NH2. So definitely that will be a neutral amino acid.
Okay. Okay. It may be neither acidic or
no. It will be neither acidic nor basic.
Okay. Fine.
Okay. Then in case of alanine, that will be like CH3. The R part is CH3.
Okay.
So it will be like CH3, CHNH2, COH. Here also we are not introducing any NH2 or OH group or COH group.
Okay, fine.
In case of tyrosine, it will be like the R part will be OH, then C4, H6, CH2. Something like this. Here also we don't have any like extra NH2 or extra COH.
Okay.
But in case of lysine, it can be represented as like NH2 and CH2 4 times. Now this is the alkyl part.
Okay, there is an amino group.
Because there the amino group will be there. So it can be generally if you want to go for the structure, it will be like NH2, then CH2 4 times. This is the R part.
Okay.
Then we'll go for CH, NH2, COOH.
Okay, fine.
Now if we compare the amino groups, see we are having 2 NH2 groups. So that means more number of NH2 than COH.
Okay.
So definitely this will be the basic.
So
amino
if there
acid.
is a more number of amino group, it will be more basic in character.
So that here in this case.
So we can make it down. Okay, sir.
So lysine will have more number of amino groups than the acidic group. So that because that is decided by the R part. this the R part. So it is having an NH2 group.
Okay.
So anyhow, one NH2 is already there in that structure. So more number of NH2 groups will make it basic in nature.
Okay.
But I think it's not clearly mentioned in the textbook. But it is provided like in a tabular column.
Yeah.
In a tabular column, it's provided like the R part in serine, alanine, tyrosine, lysine, because it's mentioned like the two types of the essential and non-essential amino acids is mentioned in the textbook.
Yeah.
So in that part, they have classified like whether it is in essential or a non-essential part, and they have mentioned the alkyl part in each that amino acid.
And also there is a single word is given, that is basic amino acid.
Yeah.
And there is
that word is given, the basic, because in that classification it comes.
Yeah.
The basic amino acid, neutral and acidic.
Yeah.
Then we have alpha, beta, gamma amino acids, essential amino acids and non-essential.
Non-essential
The different
amino acids.
classifications are mentioned. So this is the answer. So lysine, because we have more number of NH2
NH2 group.
So option D will be the right answer.
That's the fourth one will be the right answer. Okay, fine. So we can go through the next question.
Next
Sir.
one.
When we are going to this question, which of the following is a cationic detergent? Actually, this question is based on the chapter that is chemistry in everyday life.
Everyday life.
Cationic detergent, there is no need of going through the different concepts. We are just studying a single example that is given in our NCERT.
Only one example is provided.
Yeah, only one example is given in our NCERT. That is cetyl trimethyl ammonium bromide. That is a type of a cationic detergent. The sodium lauryl sulfate, what is that? It is an anionic detergent.
Yeah.
And the sodium stearate itself is a, what is that sodium stearate? This is a type of a soap.
Soap, yeah.
So in the case of a sodium dodecyl benzene sulfonate, what will be the concept?
That will be like anionic.
Anionic detergent itself. So there is only one single example is given here, that is cetyl trimethyl ammonium bromide. That will be the cationic detergent.
And they know what are the applications of these cationic detergents and so on. So it's a very direct question. So we can like the option C, option.
And also, sir, when we are going to this concept and when we are studying the chapter that is the chemistry in everyday life, we are studying the cationic detergent, anionic detergent. I think in the page number about 460.
Last part.
Last part, that is 460. You can see directly which is the type of a cationic detergent. That is
its structure is also provided.
Yeah, structure is also provided there. That is cetyl trimethyl ammonium bromide. I think so. We can go through our next question. So you can go through this question.
Find out the solubility of nickel hydroxide in 0.1 molar NaOH, given that the ionic product, means the solubility product of NiOH twice, is 2 into 10 to the power minus 15.
Okay.
Means KSP is provided. And they are asking to calculate the value of solubility, S. But the thing is that even though they are asking to calculate the solubility of nickel hydroxide, but that substance is present in 0.1 molar sodium hydroxide. 0.1. So we need to consider the OH part from 0.1 molar sodium hydroxide.
And also there is OH part here.
The OH part. So we'll go for the reaction. So NiOH twice can be written as like.
Okay, sir. You can carry on.
NiOH twice. That will give on dissociation, like it will be like partial dissociation. Now Ni2 plus, and we'll be getting 2 OH minus.
Okay.
Now this is the dissociation of nickel hydroxide. So if S is the solubility of Ni2 plus, then 2S will be the solubility of OH minus, because we are having two molecules of OH minus for each molecule of Ni2.
Okay, fine, sir.
But now the solubility, if you are calculating the solubility, we'll get KSP is something which is equal to like 4S cube will be the answer. KSP is equal to 4. We have an equation like AX BY will be equal to X raised to X into Y raised to Y into S raised to X plus Y.
Yeah.
So students may be knowing this equation, so they can calculate the solubility. But the thing is that they are provided with 0.1 molar NaOH. So NaOH, we know that it will get completely dissociate.
Okay.
NaOH will get dissociated as Na plus and OH minus.
Okay, fine.
Okay, now it is 0.1 molar NaOH. If it is 0.1 molar OH, after complete dissociation, it will produce 0.1 Na plus and 0.1 OH minus.
Okay, after complete dissociation. Okay, fine.
Now KSP, if you are calculating the value of KSP, that's equal to concentration of Ni2 plus, okay, into concentration of OH minus. But here we need to consider the concentration of both from NiOH twice.
Actually,
and
because
also
both the concept they're having the
OH group. So that we have to the 0.1 that will be contributed from sodium hydroxide. So the net value will be 2S plus 0.1 in case of OH minus. The
Okay.
concentration of OH minus will be, you can write like concentration of OH minus, that will be equal to 2S
Plus
plus 0.1. But the solubility will be very less because this is a sparingly soluble salt. So that S value will be very, very less.
Okay.
So that if you are comparing with 0.1, we can neglect that 2S value.
Okay.
Because S will be very less, so that 2S will be very, very less. Because
Okay.
it's like a decimal. Okay.
Yeah, fine.
So we can say like 2S plus 0.1 will be approximately, that will be equal to 0.1.
Okay, we can neglect that.
Yeah, 2S will be neglected.
Neglected. Okay,
because when
fine.
on compared to 0.1.
Okay, fine.
So our answer will be KSP will be equal to KSP is equal to Ni2 plus, that will be S, into OH minus, that will be like 2S plus 0.1, and we have considered it as 0.1.
0.1.
So into 0.1 square. And the value of
Okay,
KSP,
fine.
ionic product. Now the answer is there. Because the value of ionic product is given like 2 into 10 power minus 15.
Yeah.
So KSP. So we'll apply that value. So 2 into 10 power minus 15. 2 into 10 power minus 15. That will be equal to S into 0.1 square. 0.1 whole square. That will be like 0.01. So S will be equal to 2 into 10 power minus 15
Multiplied.
divided by
by
0.01. So 0.01, we know that it is like 10 raised to minus 2.
Yeah.
So if that 10 raised to minus 2 that comes to the top,
10
that will
raised-
be
it will
10
be
raised to 2. So 10 raised to 2 into 10 raised to minus 15, that will be 10 raised to minus 13. So the answer will be 2 into 10 power minus 13 will be the right answer.
This is the final case.
That will be the final answer.
Okay, fine.
So
So this will be the solubility.
That will be the solubility
That
of
will be the solubility condition.
that S value.
So here the answer will be, that is 2 into 10 raised to minus 13 molar.
Yeah.
That will
That's,
be the,
now we can see the value of S. 2 into 10 raised to minus 30 means 0.00000000, that much 2. So
Yeah.
13 zeros will be the. So that definitely we can neglect from
neglect that
0.1.
2S value
That's
there.
why that we have neglected that S
okay.
value.
Actually, I think this question is only little bit
Yeah,
twisted.
that will be because they have considered this 0.1 NaOH.
That is
we
it.
need to
Both the
yeah.
NaOH is considered.
Yeah.
So both the equations contain the OH.
So this we have to 2S plus 0.1. That
yeah.
has to be taken.
And the 2S is neglected.
That will be neglected.
Okay, fine.
We can neglect if we otherwise if we are not neglecting our this equation will get complicated.
Okay.
So that will not be getting the perfect answer. So it's better to neglect and we'll go ahead.
Go through the reactions. Okay, fine. So we can go
We'll
to
go
the
to next question.
Next question.
Yeah.
Actually, in the next question, identify a molecule which does not exist.
Yeah.
Actually,
An imaginary molecule.
Yeah, imaginary molecule, and we studied the same concept always in the chemical bonding about the bond order and their concepts,
Bond
and we are
order.
studying that a molecule which does not exist, that is helium-2.
Yeah, that
Helium-2 having there is no bond order. We can
Total
say.
4 like sigma 1s2, sigma star 1s2.
Yeah, sigma star 1s2. So we can say there is we can say this molecule is does not
exist. So that they need to calculate like bond order half into Nb minus N.
Yeah, Nb minus N.
But I don't think their students will be doing because they know because He2 molecule is
because
imaginary.
always in every exams
Yeah.
we are giving also.
Yeah, it's
the
an application
same,
question.
Yeah, in the same question is repeating again and then I think the previous NEET exam also the same question is coming.
Okay.
In 2013 to 2018.
He2 molecule.
Yeah.
Yeah. Usually we used to get like it is imaginary, it is hypothetical. Now what is the reason like He2 molecule is imaginary? So its bond order is 0. It never exists.
Does not exist. Okay, fine. So students, we can go through our next question. So
option 1 will be the right answer.
Option
for that.
1 we already got that concept.
Okay.
So we can go through our next question.
Yeah, we are with the last questions now.
Yeah, we are within the 44. Question number 44. The following metal ion activates many enzymes participate in the oxidation of glucose to produce ATP and with Na and is responsible for the transmission of nerve signals. Actually, this concept we are studying the chapter that is S block.
S block. Biological importance of sodium and potassium.
That is biological importance of sodium and potassium pump.
Yeah, now the answer is there.
That the sodium and potassium pump, that is the transmission of nerve signals, that is potassium. And there is no need of going for iron, copper and cesium. And there is a direct question is based on our chapter that is S block.
The biological importance of sodium and potassium.
Yeah.
So we'll move to the next
one. Actually, based on this question, This is the one and only one question that is from our chapter, that is structure of atom. And this year there is no question from quantum numbers.
No question.
And the probability density,
no hybridization.
No hybridization, no probability density, no quantum numbers, and also there is no questions regarded to the, actually sometimes there is a questions maybe regarded to the Bohr model.
That is no hydrogen spectrum.
Yeah, no hydrogen spectrum, no Bohr model. That much concept is not.
That means the question does not go to that depth.
Yeah. Actually, it is a average.
It's an average question.
Actually, I can say the below average sometimes. Okay. So we can go through. Actually, the NTA today, this year, this question is based on the. Actually, this question is based on all the students. Yeah. Actually, this year some students is affected by severe COVID cases in some situations, in some, not only in our locality, maybe in all other locality, the NTA is considering this year. That's why the questions in the average level. And if this year, if the students studied very good through their NCERT, they can score a very high marks.
This time NCERT will be.
And last time also in 2019, and even though when you are going to 2018, 17, for 16, everything, the Bible you have to study here. It is the NCERT. And the further thing, you can refer any other books, even though for the chemistry we can search any other physical chemistry books or any other Pearson books for the organic chemistry or inorganic chemistry, anything you can.
But the base, as you told, the Bible should be NCERT text.
The Bible should be NCERT always. So we can.
So we'll move on to the next question.
Okay. The number of proton, neutron, electron. It's a very simple question. You know that concept, that is atomic number is equal to number of proton is equal to number of electron. And the mass number is equal to mass number. I'm just writing here mass number A is equal to number of proton plus number of neutron. And number of neutron is equal to mass number minus atomic number. If you know this concept, these three concepts clearly, this answer is very simple. See here, 71, 165. So you have to get the number of proton. Proton, I said it is equal to the atomic number. So here the 71 will be their proton itself. So you got here proton is equal to 71 itself. Now you have to find the neutron. How can you find the neutron here? This is 71. Neutron is equal to, that is 175 minus 71. That will be the answer. 175.
That will be 104.
104 will be the answer. Okay, fine. So what will be the electron here? Electron, that will be
a neutral atom.
The neutral that we can say, that is Z is equal to P is equal to E. Then E equal to also 71. E is equal to also.
So the sequence will be 71,
104, 71. So 71, 104, 71. What will be the answer? The first one will be the answer. Others are.
And also they know like number of protons and number of electrons will be same. So their first and third answer should be same.
That
so
is
only
71,
one option 71. Is there, because in all other answers the first and last options are different. So they can go for like 71, 104 and 71. It's a very easy question.
Yeah. So see here, students, now we discuss all the questions. I think we discussed all the questions related to
all the 45 questions.
45 questions we completed based on our this NEET 2020. So all of my dear students will please go through the concepts once again. Please go through the concepts very clearly, and definitely if you have any doubts, you can message us through our YouTube channel, or you can message us through our app. And you are always welcome to join our app, that is Bright Learning app. That is all over in our Middle East. And you are always welcome to join our Target Learning app, that is all over in India. So you are always welcome, your students, especially the Target Learning app. You can now it is in Kerala only, and it will be ahead in the next year onwards. It will be in all over in India itself. Okay, so see us, students, and
students they'll be busy calculating in their marks.
Yeah, definitely they will be busy.
Yeah.
So
we are will all the best wishes for them.
Yeah, definitely. And we are winding off. I'm myself Nishad, and he is Mr. Irshad. We are both of our faculty of chemistry, and we can see with another things and another videos. For that time, goodbye. Thank you.
Bye.